Welcome to examples from chapter 1 of CSE 259. In this, we will be looking at the natural deduction rules, examples for natural deductions in propositional logic. So let's get started. Before we jump into doing a couple of examples, a quick review of the natural deduction. So the first is that of conjunction. Given two formulas phi and psi, then you can conclude phi and psi. Given phi and psi is true, either you can assume phi is true or psi is true, and those are the elimination rules. The disjunction rules, if either phi is true or psi is true, then phi or psi is true. So these are the introduction rules, and the elimination rule for disjunction is given phi or psi, assuming phi, if you come to a conclusion of another formula x, and if you assume psi and you come to the same formula, then you can say x is true. I think by now you would have noticed that looking at the truth tables makes it easy to understand these formulas. So write out the truth tables for conjunction and disjunctions, negations, to understand how to do these formulas better, because they are directly a result of the truth tables. The other example is with respect to, the other rules are with respect to negation. Given a formula phi, if you can conclude false or it doesn't hold, then the negation of the rule is true. This is the implication rule for introduction rule for negation. Similarly, the given false, then you can assume that phi is true. If both phi and not phi are true, that means there is a contradiction, so you have a negation rule. Then you have the double negation rules, that is not phi is same as phi, and phi is the same as not phi. So one is the introduction rule and the second is the elimination rule. Now looking at the rules of implication, phi, if you assume phi and come to a conclusion psi, then phi implies psi is the introduction rule for implication. And if you're given phi and you're given phi implies psi, then you can say confidently that psi is true. This is the elimination rule of psi. Again, look at the truth tables for implication. It should make a lot of sense once you are clear with the truth tables. Similarly, you have modus totalens, which is if phi implies psi and not psi is given, so not psi is true, then not phi is true or phi is false. Similar to the negation rule, if not phi comes to false, then you can assume phi. And the second rule is called law of exclusion or lem. That is, you can always assume either phi is true or not phi is true. So this is just a line above, so there is nothing. Given nothing, you can always assume that if phi is true or not phi is true, one of the two formulas always holds. So now, given these rules, let's move into doing a couple of examples. So our first example is P or Q implies P, the whole thing and Q. Then we can validate that P is true. If this is true on the left-hand side, then P on the right-hand side holds as valid. Okay, for this, let's start about doing this by writing the, or let me write out the way it should be proved. So first is, what's my premise? The left-hand side of this is my premise, that is P and Q implies P or Q is my premise. Now, using the elimination rules of AND, I can get Q over here. So that is the elimination rule, keeping the second part of the AND formula. So that is this one, and I have 1. Now this is the statement from which I am concluding my rule. So I need to provide the statements, and remember these statements have to be provided in the particular order in which we are concluding our rules. I can also say P and Q implies P, which is the first part of the AND, this one, is also true, and that is from the elimination rule 1 from 1. Elimination rule of conjunction. So the rule is phi and psi. I can say phi, which is the elimination rule E1, and I can also say psi, that is the elimination rule E2. So these are the two rules that I have used in the opposite order. Okay. Now, given this, I need to show that uh, P is holds. So now in 3, I have uh, an OR here. So I can go about the way to prove for OR. That is, now I assume Q implies P. Okay. So this is assumption. Why am I making this assumption? Is if you remember the formula phi or psi, then if I am taking phi and I come to the conclusion X, and similarly if I take psi and I come to the same conclusion, then I can say uh, X holds or alpha holds, whatever we look at this as. It has to be the same values on both from phi and psi. And this is the elimination rule of uh, disjunction. So assuming P implies Q, I can now say from 2 and this that P holds. This is the uh, elimination rule of implication. So what am I using? I'm using 4, which is the implication rule, and 2. Now remember the order in which I'm writing over here, 4 and 2, because for given that implication and given phi, I'm writing this. Okay. Now 6, I can also assume P. This is the same thing I'm using over here as the rule of phi or psi being true. Now from this, I can state P, because P given phi, I'm getting to P, and given psi, I'm coming to P. So P can be true as this. And remember again what all I'm using. I'm using 3, the box 4 and 5, and the rule, and the box 6. And so I've proved the validity of my P. The second thing, let's look at another example. Here, if P implies Q and R implies S, then I need to prove P and R implies Q and S. So what are my premises? I'm given two formulas here. So first premise is P implies Q. Premise 2, R implies S. This is my premise. Now I need to prove this. Let's look at the implication formula. It says, if I have assumed phi and then I conclude psi, then I can say phi implies psi. This is the implication introduction formula. So keeping this in mind, I'm going to prove you. Remember, it says assume. So I'm assuming P and R. So I always assume the left-hand side of the implication and prove the right-hand side. So P and R. So this is my assumption. So given P and R, what can I say? First is P. What rule uh, of conjunction is this? So I'm using the elimination rule 1 of conjunction, and the line is 3. Now from this, I can say Q. And that is the elimination rule of implication using lines 1, comma 4. Similarly, now I can say R, which is the rule you have seen multiple times. Now I can say S. Again, I'm using the elimination rule here of 2, comma 6. Now from this I can say Q and S. This is the introduction rule of and the lines I'm using here is 5, comma 7. So this is my assumption. From this I can say P and R implies Q and S. How do I say this? Using this, that is the introduction rule, using this rule over here, introduction rule, and the box in the lines I'm using are the complete assumption box, so that is 3-8. So I've got my conclusion. So this is the way you check validity of formulas. So the formulas, again, a quick recap: whatever is given to you on the left hand side becomes your premise, and you prove whatever is given on your right hand side. And to do that, remember what you use your formulas of implication or rules that you find in natural deduction. Look at the exercises for more such examples, and I think remembering your truth tables should help you do it more easily. Thank you.